Hello everybody, I'd like to welcome you to my YouTube channel for C64 Brain. This is Steve coming back with the next video in this series here. So in this session we're going to actually be covering two videos. That's going to be video 5 and video 6, which includes both the animation and the gravity. And the reason why I combined it is I felt that the video 5 was actually pretty short, when it only just covered a little bit of the punching animation. And video 6 is actually given a little bit more information about when a player falls off a ledge, gravity will be taken over at that point. So let's get this started. And we now present the Commodore 64 game project, video 5. Okay, and as always, as mentioned, I appreciate you subscribing to my YouTube channel. It'll help me grow, and also leave your feedback on the Facebook page if you have more in-depth questions about, coding and stuff like that, but you can still leave comments below in the YouTube as well. What will be learned in video 5? Learn how sprite animation works. The sprite animation starts its execution after player init routine is called, and then there is a subroutine, JSR animate sprite, that initializes the sprite animation and the timers used to control how fast the animation goes. The next subroutine is handled when a player moves left, right, up, or down, remains idle, or when the player moves the joystick to the upper left or upper right, which currently shows the punching animation states. Then a call is made to init sprite anim. This captures the sprite data animation frames, saves them in a table, and then sends this data to register screen mem plus the hex of 3F8. Think of this as like changing registers 7F8 through 7FF when pointing to bank 0, which is the default at startup. Now we're on to main.asm. Since we are only changing sprite animations in this project, the main.asm routine has not received any new code, so we can skip this part. For reference, all the inks seen below manage the sprite data. We will be focusing on the area inkbin yoursprite.spt, 25, 28, and inkbin yoursprite spt 29, 34 for the punching up to the right and punching up to the left animation. The other animation for kicking will be used later as the project evolves. And these are just going to be those different animations that are included inside of the CBM-PRG Studio Sprite Editor. Now we're on to playerroutines.asm. First, let's add in the new states for punching right, punching left, and kicking right. These are appended from where we left off in Project 4. And if you remember the last video, I showed the left, right, up and down movement states, and now we've already added our new one, which is our punch right, punch left, kick right, and kick left, and the word tables are below. Now for our subroutine player state idle, these are the new changes. Our punching animation state is now added, so we include the new code below. And you can see here, I wrote under player state idle, check if sprite is punching right. And what this is doing right here, where it says check up right, this is checking the joystick as you're moving it. I don't know if you can see me here, but as you're moving the joystick up, direction like that, it's going to check for the right movement right there. And then, of course, the left movement is for the other one. And check if sprite is punching left. Player state punch right. Before we set up the action, when the player sprite moves the joystick to the upper right, then the punching animation takes place. So in this subroutine, we're now including the punching right. So now that we move the joystick, it's calling this subroutine, which is going to, if you remember, it's going to load those animation states, pulling directly from the CBM-PRG Studio sprites and storing them in the 0-page pointers, low and high bytes. And it basically sends this call off to our animation to basically pull those and set those directly to the sprite frames that are seen on the screen. And here we have the joystick test. This is the same as usual. Just test for the joystick, waits for it, and then we execute the regular code here where we check to see if the joystick's idle. And if it's not, if it's idle, that means no joystick movement's taking place. So the sprite animation is the walking state up and down. Now for the player state punch left, below we set up the action when the player sprite moves the joystick to the upper left, then the punching animation takes place. So this one, like the right, is now for the left animation states. And same thing with our joystick calls. And then our regular idle again. Now here's the one I haven't added in. This is the player state kick right, which is pretty similar to the punch, except I haven't really assigned it to any joystick positions, but it could be used later. I just wanted to show you that it could be included. And maybe we'll do some examples in the code examples. Same thing, we're checking for idle. And here's the player state kick left. And the same thing, we're checking for the idles. Now for the sprite routines.asm, we are now implementing the subroutine init sprite anim. You can see it right here. And I'll just jump back here for a minute to show you something here real quick. So pay attention to everything above this point because it's going to be calling directly into the sprite anim. So what we're going to be doing is our 0 page pointer 1 and 0 page pointer 2 are containing our, in this example, it's our kick data, but we'll concentrate on the punching sprite animation since that's what we're seeing in this example. And now it's storing a 1 into this register, but remember the 0 page pointer, that included our sprite data that was being, for the punching example, we'll just say that this one is a sprite animation, which is the animation player punch left or punch right. And this is storing this inside of a table called sprite animation, which is used to check which sprite animation is taking place, because the X is always indicating which sprite is actually currently active. And here you saw we just transferred the X to the A, and then we basically shifted left, and then we also transferred A to the Y to get it to the sprite table there. Okay, and this is actually calling in that individual data sprite. So from the CBN PRG Studio editor, it'll be the punch in left, the two different animation states where we have punch in left and punch in right. And whatever the animation states are, even whether they're moving left, moving right, it's all going to take place here in the animation states. And then we just set the sprite image. And from the, I didn't show it here, but on the last example, it basically just sets the sprite pointers to memory so that they show up on the screen. And here we're checking if there's a second sprite, but this one really isn't implemented yet because we don't really need to really take care of the legs until much later. This is added for the swimming animation for later. And here's the tables that we've now appended. So I wrote animation states here are punching and kicking. As a reminder, these are read from the subroutine that moves the joystick, player state walk right, player state walk left, and so on. And these are the new ones we added, our animation player punch right, which you saw earlier, our punch left, our kick right, and our kick left. And as usual, remember these are going to be the timing bytes that are being sent. These are the sprite data. Those are those ones being saved in those 0 page pointers and read to the sprite shape data. And then this is our animation states, which keeps track of whether it's a ping pong, like a ball going back and forth. And then there's also one here for a loop, which is for these kicking states. And then these are the data that checks the upper joystick to the right and upper joystick to the left. And that's pretty much it for this part. Hello, everybody. I'd like to welcome you to the second part, which is Commodore 64 Game Project Video 6. And as always, I appreciate you subscribing to my YouTube channel and responding on the Facebook. And you can always get the code for both examples here for Project 5 and Project 6 at my GitHub. What will be learned in Video 6? We are finally going to add gravity to our player sprite, so whenever a sprite has no ledge underneath them, they will free fall. Note, I won't be able to demonstrate walking around the map a lot since we now fall when not touching anything, and the ladders don't work yet. However, stay tuned to the next project where a sprite will be able to climb up and down poles. Good stuff is on the way. So essentially what we got going on here, as since there's all going to have gravity in this example, as we move off a ledge, we'll keep falling until we hit the floor, but we won't be able to walk back up the screen. So the ladders right now do not work until we implement them for the next stage. Now we're on to the main.asm, and this one there's no changes being done for this project video. Now we're going to look at player routines.asm, and we are going to add the new subroutine called apply gravity. Now we begin checking if the joystick has been moved to the right. This is necessary since moving to the right will not change if the sprite has fallen off a ledge. And here I wrote check if the joystick is moved to the right. So here we're going to be checking the joystick. That's what this is doing, is checking the bit values of this joystick. And it's going to send a call here to test right move if it found that the joystick was moved to the right. And this one, if it's not moved to the right, it's going to fall out down here and move to the left and set those calls to the joystick. So the left routine takes over. Now we begin checking that the joystick has been moved to the left. This is necessary since moving to the left will not change if the sprite is falling. And then our joystick was pressed to the left, and again we're checking those subroutine calls, the bit values for the joystick to make sure that this is a left movement taking place, and then otherwise we're done with the movement. Otherwise we're going to do something different down here, which is check if the sprite has landed on the floor or ledge. So if he's not moving to the left or right, we're still got the applied gravity that's going on at all times here. So now we're going to be seeing what's really going on with this sprite here. So what we need to do is we're checking the bottom sprite at his feet, because as he's falling, we're going to be checking where his feet are. And we're going to use a subroutine called check block under. Here I wrote first check if we are on a pole. So also if he's on a pole, it could check if he's on a pole or if he's just sitting on top of a building somewhere. And then we're going to check the attribute or the materials data in the variable called collider attr. And then we're going to check if there's a floor. If there is a floor, then that means there's no falling. So he's on the floor, he doesn't have to fall. But if he's not on a floor, then he will be moving down. So essentially he's just going to keep falling. So I wrote sprite will now fall since all blocks, tiles are clear. And that'll be demonstrated in the code example in the next video. The new changes include checking for gravity when the joystick is not being moved, and also checking to see if the sprite has landed on a floor. So the new implementations we have, I wrote sprite has landed on the floor. And again, we're going to check this block to see what is the data underneath our sprite, under his feet. And if there's a floor there, then we're going to implement the subroutine down here where it says if it's not a floor, this means that he's still falling. Otherwise, down here, it detects that a floor has occurred. So if he, for example, as he's falling, we need to check underneath the sprite. And he's going to keep falling. If he's not still falling, which is down here, then he's going to be able to land on the floor. And this is what happens when he lands on the floor. So I wrote, sprite has landed on the floor, so move sprite up. And this fixes below floor bug, I wrote. Because what happened is initially when the sprite fell and he landed on the floor, he would get stuck in the ground. So now, if I move him up, he doesn't get stuck anymore. Now for the player state walk right, these are the updates. We check the right subroutine since holding a joystick to the right will not manually read the apply gravity subroutine, which makes the sprite fall down, which we saw earlier. So this is checking our sprite data here for our tile underneath our sprite. This is our feet again, right? Because we've got our 0 and our 1 sprites that are stacked on top of each other. And we're going to see if there is a floor here taking place when he's moving to the right. So as the sprite keeps moving to the right here, we want to see, first of all, did we encounter a pole or did we encounter a floor? And if we did, we don't want the apply gravity to take place. We want to basically jump out of this subroutine, allow him to keep walking to the right. Now for the player state walk left, we check the right subroutine, or the left subroutine, since holding a joystick to the left will not manually read the applied gravity subroutine, which makes the sprite fall down. And again, this means if he's moving to the left, we're going to be checking that tile to see if there's a floor or a pole in the way. And if so, then we're going to be able to stop since we've encountered something in our way, which is a tile. Otherwise, we're going to keep falling. Finally, I want to thank you for watching as always. I personally really am so glad you guys are keeping up with the series, and I'd love to hear your questions and everything. I hope you guys are learning something, and feel free to go ahead and leave your questions, everything below. Just keep the Commodore 64 alive after all these years, and feel free, as always, to share this with anybody who has a need and interest. Thank you so much for watching. Have a great day.